over the past few years, 3136 has made a splash in the Chesapeake District. Now they're here to present their robot and the amazing risk mechanism that they provided, the unique climber that they have for this year, and the code that makes it all mesh together. Let's go ahead and go behind the bumpers and learn more about O.R.C.A. All right, so tell us a little bit about this interesting wrist design. What all goes into it?
Our wrist is a heavily modified version of the West Coast Products wrist. Up top, we have our rollers for intaking coral and outtaking coral. On the bottom, we have extra wheels for intaking algae and taking it off the reef. Our whole wrist itself is powered by one central vortex, neovortex motor, which allows us to maintain a sleek design, which helps us stay away from hitting the belts and maintain a slimmer, more maneuverable elevator frame. Our wrist is also attached to an encoder, which allows us to get accurate information about its positioning, which allows us to input it into our system and use it for manual rotation, automatic rotation, while being able to avoid hitting it on necessary parts such as the elevator.
All right. And let's go, if we can go and turn around this robot and see this impressive climber design, looking all like a whale fluke itself. So tell us a little bit about how you designed that.
So the design of the climber, we use the basic of the EveryBot climber, and we used that, and we were trying to decide on how we could get the geometry correctly for the climb, as we have little space to work with. So we saw that the Rembrandts had a very good foot design, so we decided to reach out for them to help, and we have since then created a good bit of variance off of that. And as you can see here, we automatically set it out, which locks the foot here with a linkage that it overextends past the rotation point, so that when you push up against it, it goes against a bolt, which is a immovable object per se for this climb, as well as in the automated side of the climb, which we will go into further later. It lifts this funnel and out of the way of the chain. And to simply put it, the cage lines up like this. We use this foot as well as the geometry of the whale tail, as we call it, and the camera as vision, to line up, get the cage in here, and then pull it back until it is into our robot and we are off the ground.
All right. And so you guys have boasted a lot about the amazing code that makes all this work. Tell us a little bit of what went into that and how you guys made it work for you.
Let me pass it off to Phil.
Yeah, so I automated most of this thing. So at the press of a button, it flips this up, it puts that out, and then when they're ready, when they have the cage on, they just push the button again and it climbs for them. And I did the same thing for the intake. When they have it in position, all they have to do is push one button and it knows which way to go to score. And I also did that with the set points of the elevator. So they push another button and it goes to whatever level they want it to be at, and then it stays there.
Thank you so much for taking the time out of your day. Congratulations on the progress you made at this competition and winning the Gracious Professionalism Award today. I can't wait to see what you guys do for the rest of the season.
We are excited as well.
Real quick, do we want to do some O.R.C.A squats?
Yes, please.
All right, everybody join in. O.R.C.A, O.R.C.A, O.R.C.A.